Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Wi-Fi roaming and mesh. So let's dive right into it. Now, why exactly do we have need of this Wi-Fi roaming and mesh and all that jazz? Basically, Wi-Fi went from something that cool kids use to something that every Tom, Dick and Harry uses, including mom and dad. So we need a lot of Wi-Fi. Nowadays, meaning coverage-wise, Wi-Fi really matters. And single point cannot cover it, no matter how powerful equipment you buy, no matter how expensive it is. It cannot just take care of everything. It cannot do that coverage. So the only mathematical solution to that is multiple radios. Now, basically the Wi-Fi part is the radio. So we need multiple radios. And roaming is the ability to move from A radio to B radio without user intervention. Meaning right now you can have just like two systems, two Wi-Fi network, two Wi-Fi passwords, and you can log both on in, and then like once you detect, hey, one is not working, you are in the second coverage, you switch it. That's user based. That's not roaming. Roaming has to happen on device end without user intervention, meaning device takes care of it, you do not get to know about it. Like ideally you will not even notice it. That's the most optimum scenario. And it needs to also allows the ability to bond multiple radios. It just cannot be A and B. It has to be like A to 500 if needs to. So multiple radio bonding needs to be compulsory. And Wi-Fi client, basically whichever device that's receiving Wi-Fi, that is the one that is going to do the hopping. Access point can't actually do that, so they will do that. And it has to be seamless and invisible to clients, meaning people who are in a cafe, they could be connected to multiple access nodes, they will not even notice it. They're not supposed to notice it. You can be in office. I have seen like there is a lot of places in India that is offering, especially in Bangalore, that's offering working space. People come in and they have to invest a lot on Wi-Fi. Meaning even in like a small space, you will find like they will have 4 or 5 access point, and not to mention most of them are doing what we call load balancing. And the reason for that is very simple. If one access point is connecting to too many high throughput client, it will be saturated. So even though it could give you high signal intensity, it will not be able to dump enough data to you. So connecting to even a weaker signal in those scenarios may yield a better result. So load balancing is important, and that's another aspect of it. Wi-Fi went from to like, no, we need it. Like we really need it. Many office nowadays have laptops as primary system, and many of them do not have Ethernet connection as a default one. And not to mention, many ultrabooks do not even have Ethernet port anymore as a default thing. So Wi-Fi is a very critically important thing, and you do need a lot of radios in order to cover a large area. And at that point in time, if you do not have seamless running, it will become a hassle. Now, it will still work, it will be just a hassle. So what about this mesh? Because I'm reasonably like my old router died from a power surge, so I had to buy a new one. And I noticed, I'm pretty sure most of you have noticed, whatever you buy, you will have things like this. Like this is from TP-Link. It has one mesh. If you buy from Asus, it will say Air Mesh or AI Mesh, whatever have you. So what is this mesh? And you must have seen people are selling you like a packs of 3 or 4, or like, you know, one, or just buy another whenever later. Those are basically mix of two things: proprietary technology and standard technology. Be mindful, Wi-Fi has to work on your client, so it cannot be proprietary, but how they deal with amongst themselves, amongst the nodes itself, that is proprietary. So it's a very good solution for small to medium scale basically. Now what is the critical aspect is here, that the same thing was already done. Like you could go into even offices, and I'm pretty sure if you must have visited any office as early as let's say 2012, you must have noticed they have multiple access point, and the Wi-Fi is just working. It's just a thing that is there, it's working. It's just that nobody needed to do that in small scale. Like basically we had the world, hundreds of node, one node. Nothing had in between. This mesh technology is specifically targeted at that zone. That zone basically where one is not enough and you don't need more than 10. Like that exact zone is mesh's main ground. And the idea is that this puppy will be expensive because it does have proprietary technology, but it will be hassle-free. And many times they will be wireless, which I generally hate. But again, I get it, the hassle-free experience. You just put a power adapter, you put the router, done, go home, sweet dreams. You don't have to do anything other than that. So that's the ideal scenario. However, if you buy even a little bit branded one, you will find that most of them will have option of wireless backhaul or wire backhaul, because be mindful, you only have one house, basically one entry point in your household that has the modem that gives you the routed data. So you have to cycle that data through all the nodes. So how do you do that? That is done by what we call backhaul, basically the main puppy. So that main puppy could be connected over Wi-Fi, or it could be connected over Ethernet. If you have the choice, please choose Ethernet. There is no substitute for Ethernet. Even if on paper you can find basically better throughput on wireless networks are not reliable, and not to mention the pings are dependent on other things. Meaning, if you are randomly end up in a scenario where somebody started to use microwave, you'll randomly find your Wi-Fi ping to go lol. So for that reason, trust me, don't even waste your time on wireless solution. Just get Ethernet system. It always like, people always like, hey, I did it day one, it's awesome, but somebody bought a smart light bulb next door, and now you're like, dude, why the heck that puppy is not working properly? That's why. Just connect it with Ethernet. Like, just bear the cost, bear the pain, and be happy. And nowadays, the designs are very amazing in some routers. Basically, you just piggyback from one to another. Back in the old days, it's like all of them had to come to one location. Now it's a daisy chain system. Even that is efficient. Just do it. So if you can do that. However, even though this is mesh and every Tom, Dick and Harry is calling it mesh, because of the proprietary technology used, it's not cross compatible, meaning you cannot buy a TP-Link system and then buy a D-Link and then just make them work. It's not going to happen. So you have to, they are locked in, meaning if you buy ASUS system, you have to buy ASUS only. You buy TP-Link, you have to use TP-Link. Now TP-Link is generally a really lame one, but it's cheaper one. So in TP-Link you will buy, and they will show you this diagram, one mesh.trademark. So what they do is basically they will give you one Wi-Fi router. That's awesome. Then you're gonna buy one or two extender. Now extenders are useless simply because they use your Wi-Fi signal itself to create a backhaul. Problem, Wi-Fi is half, not full duplex. What does that mean? That simply means it can either send data or receive data. Full duplex means it can send and receive simultaneously, like a Ethernet cable. So the speed throughput by default gets halved every time you go to a basically mesh node that is a repeater, and repeater has no other option, so it rebroadcasts it. It's efficient, cheap and all that jazz, but like it's really bad for throughput. And if you have multiple clients, you will notice a slowdown, bog down. So people generally want Ethernet system. That's a TP-Link one. It's like a really poor implementation, because they do not even allow you to connect other routers. It's like, I genuinely don't get it. It's like, why? Technology is not limited. It's like, oh, for our router to router, please buy this expensive model. It's like, dude, your cheap one can do that. In that regard, I do respect ASUS. They're like, hey, this is just a firmware lock that we are implementing ourselves. They're like, hey, what if even on older routers, what if we unlock the firmware? You can just connect one router to another router. So if you buy another router, the old router is not like a junk. It's an actual thing that you can put to extend your range. You're gonna have amazing time. So that's a ASUS system. I do get it why TP-Link did that, because again, people are lazy, people do want a simple solution, but again, it feels like very cheap and e-waste creating kind of thing. I do like what ASUS did. And be mindful, what you actually want to expect is a world where you go into home, your mobile phone connects into the Wi-Fi, and then you switch from one node to another node while your phone is doing the switching. You do not notice it. You are like, hey, I'm on Wi-Fi. Even if you're on phone call, it's just like, hello, everything's fine, I'm happy, and you're just moving on the stairs. It just works. You do not have drop, reconnecting, things of that nature. And especially you do not need to do manually. That's what mesh allows you. And it's a very specific tool for more than one client to less than 10 client. Again, it can stretch up more than that, but generally at that point, people will say, go to enterprise solutions. So this is the mesh network that we are talking about. Then we come to the Wi-Fi roaming. Now this is the big puppy. Wi-Fi roaming is basically a standard ecosystem, because when I talk about Wi-Fi is a standard. That's why your mobile phone works. Everything works only if there is a standard. Wi-Fi has a standard. So people realize even in early days that maybe we will need a world where we have to figure out roaming. So they built multiple sub-standards inside one major standard. So sub-standard like 802.11 R for roaming, and there is 802.11V, 802.11K. All these things are created as a like sub node basically, and it's from same IEEE. So 802.11. Now, if you buy enterprise grade hardware, you will see either these things are listed. But if you buy commercial hardware, commercial I'm saying basically consumer level hardware, you will never see those things. Now, these three things are like the main reason why enterprise world can do this so long ago. This was quarteralized in basically standardization in 2008, and by 2010 it became a thing. Right now, almost all your mobile phones have this technology built in. It's the router part that does not have it. That's why your mobile phone can go into any office and connect and work without any issue. You can switch from access point to access point. If the implementation is done properly, you can even have a video call or VoIP call without ever dropping a single packet. So it's kind of amazing. And standards allow the clients to work flawlessly. You will never notice it. That's the amazing aspect. And how the heck these protocols are doing it. What are they doing differently? Basically, they are reducing handshakes, meaning there is a lot of handshake, authentication, validation, signaling. Like there's a lot of steps like that happens from, okay, there is a signal, okay, I'm connected to that signal. There is a lot of handshake. The idea with these sort of basically ecosystem is that the handshake is done as a school system. Basically, you have one time when you scan your card to get into that, that's a full authentication. After that, they are like start to vouch for it, meaning you are jumping from one node to another. They're like, dude, we know this client. They're not gonna do the whole authentication process. That cuts down a lot of steps, and of course there's like a lot of security put into it. A lot of encryption is done there also, but it's far easier to go from inside of a network to another inside of a network rather than outside to inside network. So that's how they make sure the switching or roaming is happening as quickly as possible. And again, there are other aspects also. For example, 802.11v system, it actually kind of forces the client to like, hey bro, it's your time, switch. Or 11.k, that also has the benefit of like actually telling whole database to mobile phone, meaning your client device will receive, okay, there are 24 nodes. If you are not receiving signal from any other of the 23, you are only receiving weak signal from 24, that means you are an outside edge. Do not waste time switching. You cannot jump to anywhere else. Do not waste your pings on that. So it's very efficient. Like there is like thought and mindness to put into this. And that's why like whenever you see a ubiquity, how the heck they are supposed to work, that's what they are doing. They're using these protocols. And again, your mobile phone has it. For example, iPhones have a way of triggering this protocol. They never have this protocol because again, they are assuming you are in a household. And if they jumped from one to another, there is a very good chance your phone will try to connect to your neighbor's Wi-Fi. That will be a waste of time. So for that reason, it has a way of detecting it, whether does it need to go into that high roaming or low roaming. Low roaming is basically it's not going to try to roam unless it's like absolutely necessary. But if it goes to an office environment, it does need to do that. How the heck it's going to do that? Well, it waits for signals, meaning if it counts multiple access points, it knows that it is in a high density place. At that point, it changes its sensitivity. At that point in time, you have awesome experience. So if done correctly, if all these things are done, the proper setup, the proper client sensitivity, all of those things are done properly, everything will be done inside 50 milliseconds. And that's the window, because at 100 milliseconds, you will notice it. Around 50 milliseconds is good enough for audio, basically audio and video buffering. Basically buffer data can be there for that 50 milliseconds. So you will not notice stuttering, jitter or things of that nature. You will not notice it basically. And ideally you can do that in like 4 or 5 milliseconds nowadays. So that's the like worst case scenarios. Like you must be done the handshake port from A to B must be done inside 50 milliseconds, and no data drop. You cannot drop data packets, and only small delay has to happen. Again, not to the user. Delay as in like the electronic handshake will take delay. So that delay should be very small inside that 50 millisecond and full speed. So it's very good for enterprise and commercial grade Wi-Fi, meaning that's how if you're like, hey, I want a college campus taken care of, these are the protocols that you have to use. You're not going to use a mesh. And again, many times those people call that network as a mesh simply because mesh is a popular word, not the technical word. It's just popular. It's like how many people know that like 802.11k is a thing, or 802.2 basically 11r is a thing. How many people know that? Because again, be mindful, these things are common thing, known thing. It's just like from 2010, these are normal things. It's just like, it's not advertised. Even like try to find your box. There will be a like tiny description on radio on like, you know, certification, FC certification and all that jazz, FCC certification. You'll barely find like this puppy says 802.11 certification. That's it. Like, do you support these three certification? You don't know. Mathematically, they do. They just don't tell you. So that's the Wi-Fi roaming, the professional way of doing it. So how can you do it in your household? Well, you have to understand core logic. Core logic is that physics is still here. No amount of technology, no amount of magic meshing will solve it if your physics is messed up. So understand that part. Radio have bands. For example, nowadays, if you spend a lot of money, you'll have tri-band, meaning 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. So these are the three bands. Each of these bands have what we call channels, meaning that you do not get whole 6 gigahertz. You get like basically 160 megahertz slice at 60 gigahertz. So these are what we call channels. So there are multiple channels. And you have to do all the installations in such a way, especially if you have multiple nodes, is that all of the nodes should be on separate channel. For example, if you have 3 non-overlapping channels, meaning channel number 1, channel number 6, and channel number 11, they are radio waves wise is far apart, meaning the spectrum is far apart. That's not going to cause interference. You're going to make sure that next to each other, they do not talk on the same network, meaning reduces the physical layer noise. 1 6 11 11 1 6, meaning pay attention, the nearest neighbor is never in a point where it can interfere. If these two are let's say 1 and 1, the signal again it will work. Like if you are inside the maximum zone of 11, basically zone of 1 it will work, zone of 1 it will work, but if at the border it will be confused. It's like because both of them will start interfering, it will not work efficiently enough. So all the routers have to be on their own channel. Again, many time systems can automatically do it, but if you are serious about installation, you're gonna do it manually, because these are one of those things that on paper every company is like, oh, we're gonna automatically detect. You look at it, it's like, no, it does not work. And why the heck? Again, there's a lot of smart devices nowadays, a lot of devices that create a lot of RF noise. That noises confuses these things. So generally it's always better to just manually establish this and be like, okay, I'm done. It's always better. So each node should be in separate channel. It does not matter which channel you are talking about, like which band you are talking about, 6 gigahertz, 5 gigahertz, 2.4 gigahertz, does not matter. It just have to be on separate systems. And Ethernet backhaul must be used. And this is the only way. If you want to do in your household like this proper internet, you have to use Wi-Fi. It does not work over wireless signal. But it does give you lowest ping. That's the main advantage. You will get stability ping, meaning your ping is let's say 13 millisecond. That's what's gonna be 13, done, go home, sweet dreams. It's not gonna be like one time like somebody turns on microwave, your ping goes to 50, because again, a lot of RF interference, a lot of noise, a lot of dropped packets, it won't be there. So for that reason, Ethernet is your king, and you have to have one master router and other as many nodes as you want, dumb APs. Now I bought this one again to use as a dumb AP simply because I do have a router from my service provider, Geo Fiber service provider, and I did not wanted to do all these things simply because again I'm lazy. And again, I did not need to do that, because to do that I really need to buy 2 routers. I can only afford one right now. So in my router there is a setting, router mode or access point mode, dumb mode. I set it in dumb mode. Now to unlock that true functionality where you get true roaming and all that, and if you are doing a brand new setup, at that point in time you need to jump into what we call third-party firmware. Now you have to understand this silicon technology is kind of weird. It's not cost effective to make expensive silicon, dumb silicon, meaning expensive CPU and dumb CPU. Generally they will make big CPU. If it fails to meet the criteria, they will sell it as a cheaper CPU. That's how it's much easier. So Cisco, for example, let's say they created a awesome CPU for their enterprise grade hardware, awesome, and they're like, okay, we also want to sell to consumer. So what they will take, same CPU, of course they will cut cost on the board, the PCBs and all that jazz, antennas, number of antennas, number of port, they will cut down all of that. Well, they will not cut the cost on silicon. Again, they can't. Silicon is not something a cake you can just like whoosh, you can't do that. So they have the same silicon even on cheap router. What does that mean? That simply means if you can somehow unlock the router, as in like let go of that constraint, it's gonna fly. Like it's gonna do things that a commercial grade router can do. So what people did, people figured out to make firmwares, basically OpenWrt, and there is another branch also, DD-WRT. These are firmware branches where they will take the stock firmware, unlock it, and you will be shocked. I am talking on like cheap routers, basically let's say Archer C7s. Like you can do things on those router, you'll like, this is a commercial function. It's there, like the hardware is there, the software is there, and you were like, oh, wouldn't it overheat? No. I told you the silicon is exactly the same. It's there, and no company is going to develop a barely working silicon. They're going to make the most amazing silicon, and then you package it based on your price point. So these third-party firmware is a very big ecosystem. It's not like, oh, you are doing something unhard. It's like surprisingly common. And if you really want the most out of it, back in the early like 2000s, this was the only way people got good experience. So again, this OpenWrt and DD-WRT, these have hundreds of routers that are supported, and majority of the popular one, they are supported. The reason for that is even Asus routers are supported. So, and be mindful, many of these companies have the same SoC. So SoC could be, let's say, made by MediaTek. You'll find, hey, D-Link also had MediaTek, and TP-Link also had MediaTek. You'll find that. Or sometime other brands would be used. But that's why firmware hacking thing is a common thing. It's not like, whoa, black magic. It's like a normal thing. So the moment you go there, now you can unlock that advanced roaming function. It's like most radios have it. Again, silicon would not be built in such a way. It's like, oh, I'm not going to do that. It's stupid. So they have it. It's just that it's locked. Or the in AI mesh network, that proprietary format is like, that's using the same protocol, is just using it. Oh, I'm not going to let user access it. So because again, the moment they let user access it, that means other brand can also access it. Standardization. At that point, you can buy a TP-Link and make it love to with Asus system. Very, very weird. So Third-party firmwares allow you to unlock all of those things, and you can do things that you would never thought. Like, you must have seen a lot of videos recently about Raspberry Pi as a add filter. You can do that on router itself directly. You can just directly do that. Like, wait a minute, why don't they do it? They do on the very expensive one, even though the same silicon would be there. However, even though I'm talking about silicon, there is a chance that other things could be compromised also. For example, memory, meaning some silicon would have like onboard memory and package chip. That chip could be very small compared to like a big one could have, let's say, 256 MB of capacity. Small one would barely have like 35 MB. So installing firmware becomes a hassle. But again, these are things that are commonly people done, and I have linked a lot of amazing video down below, and you can achieve things that even an enterprise grade user, especially done incorrectly, they'll like, how the heck your household, Wi-Fi is so awesome. How the heck I can have a video call and go from floor to floor without ever single dropping packet. That's how amazing it can be done. You just have to have the guts to go into OpenWrt or DD-WRT and find your router. Be mindful, like this is Archer 6. Archer C6 is already supported. However, mine is version 4. Version till 3 is supported. So I'm pretty sure in 1 or 2 months, even this version will be supported. So I will try to do all those things that are basically router level ad block. So those sort of things are amazing. You can do mind-bogglingly good network. And I mean, like, at that point, it's a true professional network. So let's jump into the pro level, because again, big mesh network cannot be established, like inherently not designed with that. So if you need a big daddy network, you have to go into this sort of system. And enterprise networking generally is a god level problem. Again, people are paid just to figure out where to place the Wi-Fi router. I'm not even making it up. Like, they will have like actual dedicated antenna on laptop moving around. It's like, okay, this is the Wi-Fi dead zone, we're gonna put a router there. Okay, router here has too much shadow effect, meaning it creates a bad signal for other to interfere. No, we're gonna move it here. A lot of money is spent on that. And like, how do you think Pentagon gets their Wi-Fi? How do you think the Apple saucer gets that Wi-Fi? All those things take a lot of money. So enterprise level networking was a whole different thing. And components are always dedicated. Like, other than modem, everything else would be their own, meaning they will figure out which router to use. Again, I specified routers have a lot of horsepower, and they buy full supercomputer level router just so they can do everything they need to do, from blocking to filtering to spam blockage, everything they can do on the router level. Then it goes to the firewall. Firewall will filter everything. Then it goes to the switch. Switch will distribute everything. Switch will distribute every signal to access point. Access point will give it to your device, and everything would be dedicated. So in case of a failure, they can service it and have very good uptime. Now, there is no alternate to brain power. I specified that. You can easily feel, like campus A to campus B, you can easily feel which campus has more brain power poured into it. Even with less hardware, even with inferior hardware, they will have better performance. Like, flat out, you will be shocked many times. It's like, oh, I just bought the latest and greatest, does not work. Yeah. You have to study the environment. You have to know what you're dealing with. If you do not, no matter how good your hardware is not going to work. Law of physics cannot be cheated. So there is no alternative to that. And a good setup would be cost effective and stable, meaning you're not going to overspend, and you're also not going to underspend, meaning like just enough. It just works. It's just fine. Nobody has any issue with that. And home setup is a very good training ground, meaning if you ever want to jump into like big puppy things, again, these are small puppy, but if you ever want to jump there, you have to understand what are those advanced functions are in those router. Be mindful that all those functions are available in commercial grade just as an unlocked function. It's like, yeah, it's there. So as a training ground, as a enthusiast, these are much better way of getting awesome network, awesome roaming without ever vendor locking yourself. You can be like, hey, Asus, send signal properly to my TP-Link. You can do that, or to my D-Link if you want to do that. So that's the pro level. That's why I would urge you, hack the firmware. And be mindful, you don't even worry about breaking it. Many of the router have the ability to unbreak it themselves. So this was my presentation on basically Wi-Fi roaming and mesh. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.